Hi guys, this is Miss Brown speaking. So this week we are going to continue working with inequalities, and I would like to take a few minutes to review what we learned last week about graphing inequalities. If you have not completed the Desmos inequalities that was assigned for Thursday of last week, that really needs to be completed before you do this activity, or else this activity may not make any sense. So, first of all, let me remind you what an inequality is. An inequality is any mathematical statement that contains a less than or equal to, greater than or equal to symbol. For our purposes, we're not so much worried about this not equal to symbol right now. Okay, so we learned last week that when we are graphing inequalities, we have to know when to use an open circle versus a closed circle. And an open circle is just a circle that has not been painted in, like a hollow circle. And a closed circle is a circle with the center is painted. And we said we use an open circle when we have the greater than or the less than symbol. And we use the closed circle when we have the greater than or equal to symbol and the less than or equal to symbol. For instance, here are some inequalities graphed below. I'm going to look at this inequality here that says x is less than 4. So what we want to do is we want to color every number in on the number line that makes that inequality true. Remember, we are concerned with truth when we are solving inequalities. For instance, I could choose this number right here. 0 is less than 4 is a true statement. I could choose another one right here. -4 is less than 4 is a true statement. Notice we have an open circle at 4, meaning we do not include that 4 because 4 less than 4 is false. 4 is not less than 4. It's equal to 4, but not less than 4. That's why we cannot include 4, but we could include a number right here, which might be 3.9. 3.9 is less than 4. That's true. So we want every number to the left of 4, excluding that 4. So we use an open circle. Now let's look at the graph below that says x is less than or equal to 4. The only difference between this graph and the one above is this time we want to include 4. And I believe this graph had an error in Desmos. In Desmos, this just had a hollow circle, but that circle should have been filled in. I'm sorry about that error, sorry. We do want to include 4 because it is true that 4 is less than or equal to 4. That is now a true statement. And of course, all of these numbers to the left make that a true statement. So we're going to have to remember this after we solve our inequalities because we're going to want to graph them. Okay, so what we are going to be doing today is solving and graphing inequalities. So let's go ahead and review. Solving inequalities is almost exactly like solving equations. There is a slight difference. That slight difference does not matter for what we're doing right now, but it will matter for our next activity. But for right now, we're not going to worry about the difference. So let's just remember, when we are solving equations, we have a goal, and our goal is to get the variable by itself. And our process to get the variable by itself is to first undo the positive or negative constant. We can also think about that as undoing addition or subtraction of the constant. Sorry, I ran out of room there. And then that's step one. Step two, we have to undo multiplication or division of the coefficient. And I'm not going to try to write coefficient because I don't have enough room. So anyway, let's go ahead and try to solve this inequality. I also want to give you another heads up. Notice that this inequality, x divided by 8 plus 1 is less than 3. Now, kids will start off, when they first start with inequalities, they'll start off with a less than symbol or whatever symbol, greater than, less than or equal to. And all of a sudden, by the end of the problem, they have an equal symbol. Guys, you cannot change that inequality symbol. All right, unless there's a really good reason. So what I'm trying to tell you is, we start out with a less than symbol, we should end up with a less than symbol at the very end. So just like the equal sign divides our equations into two sides, that inequality symbol divides the inequality into two sides. And so we're going to get the variable by itself. Our variable is over here on the left, so we need to focus our efforts on the left. And the first thing we're going to look for is the constant, or the number without a variable. That positive 1 is our constant. The opposite of positive 1 is negative 1. You could also think of it as the opposite of adding 1 is subtracting 1. Either way, it looks the same and it works. Remember, what we do on one side, we must do to the other. So I'm going to rewrite this. And I still have x divided by 8. And then 1 minus 1 is 0, which is nothing. And that's why I'm not writing anything. Don't forget to copy down the less than symbol. Do not change it to an equal sign. 3 minus 1 is 2. So that is our new inequality. But again, we have to get the variable by itself. Right now, the variable is over here, and that variable is being divided by 8. So we undo division with multiplication. So I'm going to multiply this side by 8, but what I do to one side, I must do to the other. So what's going to happen is 8 divided by 8 is just going to simplify out to 1, leaving us with 1x. Don't forget your inequality symbol. And 2 times 8 is 16. So we have x is less than 16. So remember, we said up top that when we have a less than symbol, right here is our less than symbol, we want to use an open circle, which means we need a hollow circle at 16. So here I go. I'm going to make a hollow circle at 16. Basically, I'm just not going to paint in my circle. And then I want to color in all numbers on the number line that are less than 16. Well, this is going up by, it looks like 4s. Well, 12 is less than 16, 8 is less than 16, 4 is less than 16, 0. All of this stuff is less than 16. Okay, so that would be my graph. An open circle at 16 and an arrow going to the left. Okay, so let's look at our next example. All right. Our next example says 3 times in parentheses x minus 4, close parentheses, is greater than or equal to 6. Now, I hope that we remember with this type of problem, the first thing we're going to need to do is to distribute. Make sure, guys, that you are able to distribute. Okay, when we distribute, remember that means we're going to give out this 3 to the x. And when I say give out, I mean we need to multiply. So 3 times x is 3x. We also need to give out this 3 to make sure you understand that that is a negative 4. Positive 3 times a negative 4 is a negative 12. And then bring down your greater than or equal to symbol and 6. Okay, so our new inequality is 3x minus 12 is greater than or equal to 6. So remember, we need to get the variable by itself. The variable is on the left-hand side, and we have to look for the constant. The constant is the negative 12. The opposite of negative 12 is positive 12. You can also think about that as the opposite of subtracting 12 is adding 12. Either way gets the job done. But what we do on one side of that inequality, we have to do to the other. Okay, so I'm going to rewrite this. Notice I have not done anything with the 3x, so I'm bringing down the 3x. Negative 12 plus 12 is 0. I'm bringing down the greater than or equals to sign. 6 plus 12 is 18. Okay? Our new equation says 3 times x is greater than or equal to 18. Well, I'm still trying to isolate the variable. The variable is right here, and right now that variable is being multiplied by 3. The reverse of multiplying by 3 is dividing by 3. But what I do to one side, I have to do to the other. And 3 divided by 3 is 1, leaving me with 1x is greater than or equal to, and 18 divided by 3 is 6. Okay, so now I have x is greater than or equal to 6. Anytime we have that equal to symbol, we are going to need a closed circle. So not only am I going to put a circle at 6, I need to close in that circle, meaning I need to paint that circle. Okay? Okay. And then I need to mark all numbers on my number line that are greater than 6. So let's see, 6.1 is greater than 6, 6.2, 6.3, 7, 7.1, 7.5, 7.75, 8, 8.5, 8.75, 9. All of this is greater than 6. All of this makes it true. So that is my graph, a closed circle at 6 and an arrow going to the right. All right, let's look at our last example. Okay, our last example is negative 5 is greater than x minus 10 divided by 3. Now, I don't know if you remember this. We have solved equations like this. And if you remember, and even if you don't remember, I need you to know that the stuff on top is considered to be in parentheses. So it's like all that stuff on top is being divided by 3. We need to get rid of that divided by 3. And how we're going to get rid of that, the opposite of dividing by 3 is multiplying by 3. So we're going to get rid of that by multiplying this whole thing by 3. Okay, so we're doing this a little bit differently. But remember, what we do on one side of an inequality, we have to do to the other. So 3 times negative 5 is going to give me negative 15. Don't forget your inequality symbol. Now let's think about what's going to happen. This 3 divided by this 3 is just going to give me 1. I'm going to have a bunch of 1s multiplied by x minus 10, which is just going to give me x minus 10. So my new inequality is negative 15 is greater than x minus 10. Okay, so you might be thinking, well, what's next? Well, what's next is, remember, we still have to get the variable by itself. The variable is this time on the right-hand side. And we continually have to think, why is that variable not by itself? Well, right now, that variable is being subtracted by 10. So the opposite of subtracting 10 is adding 10. And what we do on one side, we do to the other. Alrighty, and I need us to have a lot of caution here, because if we're going to make an error, it's going to be right there that says negative 15 plus 10. Hopefully know that negative 15 plus 10 is equal to negative 5. So we have negative 5 is greater than, notice this negative 10 and positive 10 are going to cancel each other out. So we have negative 5 is greater than x. You can leave this like that if you want to. For me, it's easier when I graph if the variable is first. Notice how my variable is on the right and not the left. You can, if you want to, turn that inequality around. So the x would be first. And then you have to turn the symbol around as well. And then negative 5. So negative 5 is greater than x is the same thing as x is less than negative 5. So I hope you remember that we would need an open circle for a less than symbol. So I'm going to put an open circle at negative 5. And then I need to color in all numbers that are less than negative 5 on my number line. So that would be all of these numbers on the left. So I would just color those in, and that's the graph. All right, thanks. Good luck. Bye-bye.